Hey Noah,
Forward, right, left.
backward. You just saw it, a robot that understands my voice command and move accordingly. In today's video I am building a voice command robot using the ESP32 and a tiny machine learning model to make it respond to voice command. So sit back, enjoy the build and let's get started. First I cut the chassis from an acrylic sheet using laser cutting and drill all the holes, and you can check the dimensions in the description. To make it move I added two end-to-end motors which fit perfectly onto my chassis. These are end-to-end caster wheels, and I took off this part to get perfect height balance, then mounted it onto the chassis using these holes. And these are the main two wheels. This is 18650 battery holder for two batteries. Then I designed the PCB to make everything look clean and compact. But I have already completed my design, now it's time to bring it to life. For fabrication, I always go with JLC PCB for my projects because of its low cost and high quality PCB fabrication. And it is the leading PCB manufacturer in China, and they provide easy, affordable and reliable PCB and PCBA solutions. Click this button and upload your Gaba file. Then JLC PCB instantly show you as a preview of your board. Then you can choose all your PCB settings like thickness, color, finish and even 6-layer option. After setting everything, just add it to the cart and place the order. And here's something cool, don't miss JLC PCB 6-layer PCB special. You can get $30 off with the coupon and enjoy top quality 6-layer PCBs for your next project. So if you are planning your next circuit, check out jlcpcb.com. Link and $30 new customer coupons are in the description below. A few days later, the package arrived from JLC PCB. Perfectly packed, and the PCB quality is amazing. Okay, now it's time to assemble the PCB. First I place all the components on the board without soldering. First I am placing all the female header pins, and for the OLED display we need angle female header pins. Next these 4 male header pins for the step down converter. Next I am placing two 0.1 microfarad ceramic capacitors to help smooth the motor voltage. And this is a barrel jack for the main power input. And this is SPDP slide switch. And next 100 microfarad electrolyte capacitor. Then LED 1 kilo ohm resistor and two block connectors. This is the MP1584 which provides stable 5V for the ESP32 and other parts, and I mounted it on the male headers that I designed on the PCB. Then solder it properly, making sure the right side is connected to the input pin. This is the brain of our robot, the ESP32 DevKit V1 board. And this is the TB6612 motor driver. And for the voice control part, I used INMP441 microphone. For mounting the upper PCB, I used 60mm special screws. Now that the base is ready, I am mounting the upper PCB onto it. Then connect female barrel jack for the power input. And also I used 0.96 inches OLED display for my robot. Here's the SD card reader for saving voice command data to the SD card to train the AI model.
And I am using two 18650 lithium ion batteries.
Now let's upload the code for data collection. Open the SD save code. Select board ESP32 Devo model. Select your port and upload the code. Alright, I uploaded the SD card recording code and restarted the board. Just type the label, count and press enter. It saves the wave files automatically. Left, 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 left. It records, stop, then record again, repeating until all my voice samples are saved. Now record the rest of your commands the same way, right, forward, backward and your robot name. And take multiple recordings for each command because more samples give better accuracy. Then I remove the SD card, cut into my laptop and copy all the recordings. I organize them into separate folders for each label, and now we are ready to move on to model training. Go to the Gimbal website and click get started. You can continue with your Google account to sign in quickly. Once login, click create new project and type a name for your project and choose your project type as personal and choose your project setting as public. Next, click create new project. This error appears because I already created the project. Then click collect new data, add data and click upload data. First, I am uploading the forward command, so I type the label name forward, click choose file, select the forward folder and click upload data. The forward samples are now uploaded. Now just repeat the same step for all other commands like left, right, backward and noise. These sound recordings are about 2 seconds long, so we need to break them into clean 1 second samples. Just click the 3 dots and select split data. I do this one by one for all my recordings, so every command end up with perfect 1 second clip. And that makes the training way more accurate. Okay, now it's time to train the model. First go to create impulse. Here add processing block as MFCC, then add learning block as classification. After that, click Save Impulse. Next, I open the MFCC and just save the parameters. After that, click Generate the features. Next, I go to the classifier and apply these parameter settings. Then I click Save and Train, and you can see model is training. And finally you can see accuracy of our trained model. Then I go to the deployment tab, search for the Arduino library and select it and click build. Then Edge Impulse automatically downloads the model as a zip file. Next, open the RTOS voice command code. Then go to Sketch, Include Library, add zip library and select the downloaded model zip file. In my case, it shows an error because I already included it earlier. Select board and port, then upload the code. First, the robot stay in sleep mode only when I say its name as Noah. Then it wake up and start listening to my voice commands. And you can even train your own custom commands and names. Thank you for watching, and if you enjoyed this build, make sure to subscribe and hit the bell icon for more robotics and IoT projects.